let's just make it 2x squared plus 8x minus 7. Okay? On that one, if I were to ask you, what is the minimum function value, f of x value for this minimum? What is the minimum function value? Because that's where our application is going to come, and it should be pointed out here that if we graph this, here we know it opens up, and the vertex, well, the vertex would be what? H equals minus b would be minus 8. 2 times a would be 4. Negative 2. The k would be 2 times negative 2 squared plus 8 times negative 2 minus 7, just what we got through talking about. Would be 2 times 4 would be 8 minus 16 minus 7, so that's I believe a negative 15. And the y-intercept's negative 7. Just doing that real hurriedly, we get this. Negative 2, and negative 7. Y-intercept positive 7. So we get this. Or something close. All right, we'll say so. All right, but anyway, do you see there the minimum function value, the minimum f of x value, or in other words, y, the minimum value, the smallest, the lowest y value here turns out to be what? Isn't it negative 7? Well, the point of this is, where does that minimum occur? Well, it occurs at this nice little point we know as the vertex, okay? So the minimum here is at the vertex. Well, can you foresee any time when that's not the case? If I have a parabola that opens up, then my minimum function value, or the minimum f of x value, occurs at the vertex, doesn't it? If the parabola, that's always the case. So if a parabola opens up, the minimum is at the vertex. The minimum function value is at the vertex. The parabola opens up. And then even more specifically, which value is, our vertex is h comma k, so which value is that minimum function value? It's k, all right? Yeah, the minimum function value is the k at the vertex. So if it asks for the minimum value, it's the k of the vertex, the h comma k, so it's the k of the vertex is the minimum function value. Now, it should be noted, we'll talk about it in a moment too, the h is, where it occurs, the x value where it occurs, but anyway. All right, so that's if it opens up. What do we get if it opens down? Well, put one on here. Got a parabola that opens down. These going downward, do I have a minimum function value? Do I have a smallest, lowest y value? No, because those keep going down. So there is no minimum there. However, what do I have at the vertex? Yeah, this is the largest, whatever, that's k. Vertex is hk. So this k value here, that's the maximum function value. The y value doesn't get any bigger than k. right, of the vertex. Therefore, the vertex, so if the parabola opens downward, it swaps out. It's not a minimum, it's a maximum at the vertex. So if a parabola opens down, we have a maximum function value at the vertex. And again, that maximum value, the actual value, maximum value is the k at the vertex, okay? Yeah, so that's going to be our application here, is finding, we're going to find some minimum or maximum values depending upon whether the parabola opens up or it opens down. We can find one or the other. Now if it opens down, there's no minimum. If it opens up, there's no maximum for the entire function. So it's one or the other. Okay? With me so far? But the point is, if it asks for a maximum or minimum, guess what we're going to be trying to find? We're going to be trying to find the vertex. So this is just another vertex problem here. Find the vertex, which we had to do on those that we were graphing earlier. Okay? All right, so the application, like I said, is finding maximum or minimum of quadratic functions. All right? So we'll look at a couple of them. Here's the first one. Let's say we have a projectile being fired. So a projectile is fired upward. And its height is given after in feet. Its height in feet after t seconds is given by this formula. H of t equals negative 16t squared plus 803t. That's it. Okay, 803t. Negative 16t squared plus 803t. All right, so just a little bit about the function here. Yeah, one angle to this is at 1 second, plug in t to be 1. That would give you the height of the projectile. Then go to t equals 2 seconds. That would give you, plug in t to be 2, that would give you the height after 2 seconds. So on and so forth. So it's a pretty straightforward function. Just put in the number of seconds and that'll give you the height. All right, but here, what I want to do though is find the maximum height that this projectile reached, because, right, unless it's being propelled along by a motor or engine or whatever, we're just firing this thing up, and gravity is going to take over, and it's going to come back down. So at some point, we're going to reach a maximum here. So the question is, what is that maximum? Well, based on our previous discussion and the fact that, isn't this a quadratic function? So what's the shape of the graph? If I were to graph this is not what we're going to do, but if I were to graph this, the shape would be what? Yeah, this shape of the graph here would be a parabola. And matter of fact, it's a parabola that opens which way? Opening down. And so just to sketch a little handy reference here, it's going to look something like that. Now it's going to be probably narrower than that, but if we actually graphed it out, and it'd be much taller, okay? But the point is, yeah, it's going to be an opening down parabola. I want to find out where the maximum is. Well, where's the maximum? At the vertex, right? Just like we talked about. So this, if it asks for a maximum height, it's just asking for, basically, to find the vertex. Maximum here is going to occur at the vertex. So we need to find the vertex. How do I find the vertex? Off of one like this, anyway. One way to do it. One way to do it is use the little formula, right? The h equals of the vertex. What does h equal? Negative b over 2a. Yep. So I'm going to use that formula. Now this one, I don't have a c, but yeah, I've got the a is negative 16, the a is what's times the squared term, and then the b is what's times the t in this case. So a is negative 16, b is 803. So what does this give me for h? H would be negative 803 over 2 times negative 16. That is negative 803 divided by negative 32, which doesn't go evenly, but we can divide that. 803 divided by negative 32. I get 25.0938. Since I'm talking seconds, I'm just going to round that to 2509.09. Okay? So that's my h. K then would be what? How do I get k? Well, I don't have x's in this case. I've got t's. So wouldn't I plug this in for t in this case? Since t is playing the role of x, yeah. Just plug that 2509 in for t. Negative 16 times 25.09 squared plus 803 times 25.09. Okay, well, let's do it. Negative 16 times 25.09 squared plus 803 25.09. Put it all here at once. I get 10,075.1. So we fired that projectile pretty good, because that's right there our maximum, isn't it? This is the maximum. K of the vertex. And that is the height's in feet, so that's 10,075.1 feet is my maximum. Okay? All right, part 2 question, we might ask this. All right. Part B question, this is, call this A. That was A part. B part. How long does it take to reach that maximum? Yeah, that 10,075.1 is the maximum, but what if it asks, because it might ask, for just how long does it take to reach the maximum? Well, that's a time. I'm looking for a time. Is there anything up here that would give me a time that it takes to reach? Well, going back to what we were just talking about here, this h right here is what we plugged in for t, and t is the time. Wouldn't this be how long it takes for it to reach? Because that's the time that we plugged in to get the maximum. Yeah. How long does it take to reach the maximum? 25.09 seconds. It's the h of the vertex. So sometimes it might ask for the h of your vertex. A lot of times it'll be find the k of the vertex, but sometimes you might need that k, the h. So understand both what the h is and what the k is. In this case, the h is the time, the k is the height. So depending on what they ask. Okay? All right. Question or concern? All right, number 2. The cost in millions to produce a product for a certain company here is given by C equals 0.3x squared minus 2.5x plus 8.4, where x is the number of units produced in thousands. All right, so this function, if we were going to produce 3,000 units, plug in x to be 3, and that would give us the cost, projected cost, to produce that in millions. But that's not what we want here. A, we want to find the minimum cost to produce this product. Okay, well, keyword there is minimum. And that should trigger us to think about some things. Think about the graph here. What would the graph of this one look like? It's a parabola, isn't it? X squared, that's a parabola. But it's an A positive parabola, so that one opens up, doesn't it? And it's going to look then something like maybe this. And so, yeah, this is going to have a low point, a minimum point. But again, where does the minimum occur at? Well, same thing. It's the vertex. So the minimum occurs at the vertex. Since this is a parabola that opens up, the minimum is coming out at the vertex. So to find the minimum cost, I need to find the vertex. All right, so using my vertex formula, H equals minus B over 2A. What's B? Well, B here is negative 2.5. So minus B would be positive 2.5. The A is 0.3, so it would be 2 times 0.3. So I'm getting 2.5 divided by 0.6, which is what? 4.1666? Let's say 4.167, since this is in thousands. But anyway, 4.167, 17, something like that. Okay, how do we get K of the vertex? Well, K of the vertex, plug this in for X, right? X is 4.167, so it'd be 0.3 times 4.167 squared minus 2.5 times 4.167 plus 8.4. That would give us K. I'm just going to plug that all in, 0.3. 0.3 times 4.167 squared minus 2.5 times 4.167 plus 8.4. I get 3.19. Two places. Okay? So what's the answer here? Find the minimum cost to produce the product. Well, the answer is close. 3.19 is part of the answer, but what's the actual answer? Since that's the minimum cost, the K value. The cost is in millions. Wouldn't that be the minimum cost be 3.19 million? 3.19 million. Dollars. Yeah, we're producing a pretty nice little product. Okay, now, of course, part B then, yeah, that gives us the minimum cost. Part B is what is the how many units should we produce? Should be produced. How many units should be produced to keep costs at minimum, is how they word it in the book, I believe. How many units should be produced to keep costs at a minimum? Well, again, there's our minimum wording. And on parabolas, if it's a parabola, the minimum occurs at the vertex. So again, this is asking about the vertex. What do you think? How many units should be produced to keep costs at minimum? The K value gave us the cost, the actual cost, so it's not 3.19 units or whatever. Where do I go for this one? It's the H value, yeah. The number of units produced is the X value. Well, H is an X value, so it must be something there. Yeah, it must be tied in with this number. Now, it's not 4.167 units, though, is it? What's the answer? It is the H value. We're going to use it, 4.167, but X is in thousands. So it's 4.167 thousands, which is 4,100.